Hello and welcome to Res 5 Industries. I'm Travis and today I'm going to show you my well. Words are hard, which kind of works. It's fed from the well, goes into a indexing controller and has a single controller with timer on off. It's pretty basic. It leaks. It doesn't give me full control of each individual zone I want, but we're going to fix that. First, let me show you the before. Alright, so we're going to turn it on so you can see how well it works, pun intended. But unfortunately, it does have a bit of a leak. Now, we could just replace this indexing valve, but that still wouldn't solve my other problem of not being able to control each zone individually. And if there's one thing I want to do, it's overcomplicate this thing. So we're going to see how we can make it better. So, a little background on me. I've been in industrial automation for 9 years in the water and wastewater industry, so I know a little bit of something about PLCs and water and control of systems, so hopefully it should be right in my alley. But, you know, things get complicated quick, so we'll see how it goes. I'm excited to use this PLC. I heard about it from my friend. It is the P1AM, hope so it's right side up, the P1AM PLC. It is cool because it is programmed with Arduino IDE. I think you can use another system too. It's available on Automation Direct. Not sponsored, by the way. It's just a really cool device. And it's just so tiny. I can program it with the Arduino IDE, use the full Arduino libraries. Use a SD card slot built in. It has expansion slots. I have an Ethernet expansion slot. So this is going to be networked to my home network with a web interface to control the whole system. It's going to have, I have a I/O card for analog input and DC AC input and 16 relay outputs. I'm really looking forward to using this thing. I've also received a slightly used, slightly charred old control box that probably got hit by lightning in a previous life. But this is giving me the basis of our panel. You're probably wondering, why not just go build an Orbit or a Rainbird or some other basic system and just have it work? I want full HOA control of this. I want automation. I'm gonna have GPS time on this thing. It's gonna be, well, it's gonna be fancy. It's gonna be complicated. It's gonna be right in my alley of something fun to do and hopefully entertaining for you guys. Okay, so we have here all of the pieces that are going to go on this panel. We have our terminal blocks that can handle a little bit thicker gauge wire. We have our other Wago terminal blocks here that are going to be able to handle a little bit thinner gauge. We have a lot of old end stops, got some circuit breakers, got some high power contacts, got a 24 volt AC transformer, 24 volt DC power supply, a little bit extra DIN rail, our PLC and I/O setup, and our GPS. Now when I snap my fingers, all of this is going to appear on here in the correct spot as I try to figure out how to do it. In 3, 2, 1. Now for the fun part of figuring it out. So we're going to start at the end with an end stop. I'm going to use one black, one red. And stop, circuit breaker, and stop. We're gonna have actually no, because that's gonna be moved over a little bit. We're gonna have another end stop. Because these are going to be our pump outputs in 24 volt AC. Words are hard. TB1 works for that, because this one is going to be for our valves, all 4 of them. And this can be TB8. Now, our power supply can go up here. That can be, PLC is going to go roughly here. And we're going to have to save some space, so we got to figure out the I/O for the GPS module, which has to come into the side right there. Now for this piece, we're actually going to need to remove this DIN rail, I think. Because our transformer and our contacts are not DIN rail mountable. We'll save those, we might need those again. We got some extra holes drilled here. What are the odds any of them line up? The odds are not in our favor. Probably misdrilled some stuff before, but that's okay. We can work with that. So this can go roughly somewhere right here. Contactor 1, contactor 2. And if I bring these over just a hair more, and make them fit in real close. Hey, look, one of those will fit. We can fit another piece of DIN rail right here, which can be used for anything future we want to stick in. I'm just going to move this over to that corner because we're going to need it over there. And there's everything. Okay, so the rough plan for this. The system's going to run off of 240 volts because I do not have a 120 volt drop at the spot where this is going. There's only 240 volts that's currently running the old pump that I know of. There might be 120 hidden somewhere because the water softeners seem to run off 120, but I cannot find the outlet for it. So we're running off of what we found when we bought the house. 240 is actually going to run into the top of this terminal block. Typically we bring everything up in the bottom. This is going to run in the top. I'm going to loop wire on here to my 20 amp 240 volt breaker. And then from there it's going to run up through here, land on these 2 terminals to bring my 24 volts in to drop down to 24 volt AC over here. From there I'm going to jump it off of this into this terminals here and terminals here. And these are going to be my terminals to send power to my pump outputs, and these will run 240 back down to these here for pump 1 and pump 2. The 24 volt AC is going to run up and split into the relay outputs here for when the pumps are in auto, which really I should be showing these. We're going to have HOA switches mounted to the front of the panel. These HOA switches are going to be able to bypass the PLC entirely. When it's an auto, the HOAs will come into the input here and show me what's an auto, which will allow this relay to trigger the power to the valves. When it is in hand, it's going to bypass the this entirely, and it's just going to run 24 volt AC directly to the valve output. And that way, if something is down, I can still manually run the system. Cheap little HOA switches. We'll see how well they work. Coming up on the screen here should be a picture of my rough drawings I did. They're not perfect, they're not pretty. I did them, I think, in Photoshop or Illustrator, but they get the idea across of how roughly it's going to be electrically done. And that's the end of part 1, where we explain how we're going to do this. In the next part, we're actually going to get this assembled. We're going to start mounting everything up out in the field, and we're going to get everything running. In part 3, we should hopefully be bringing it online in auto. We'll see how it goes.